Hello, right, so this is Evan here. I'm going to try and explain a large memory family 15 issue that we're having. Okay, so I'm just going to pop out and I'm going to show you what I've generated. Okay, so I have generated a program for Great Cow Basic. It is for, let me zoom in, it is for a large memory device called, and this one is a 16F 18. So 18857. It has 4K of RAM, 4096 bytes of RAM. Now, um, this program I'm going to show you now. If I run it, I think it's the best thing to do. Look, basically what it is, it fills every byte of a RAM in memory with a specific address, and it goes through every single page. I've generated it automatically. It only took a few seconds. But what I'm going to do is I'm just going to quickly assemble that. I've assembled that. It's done it. Great. Wonderful. And now what I'm going to do is I'm going to take it into um, a program that has been written. Okay, and I can run this program, and I'm just going to drop the ASM I've just created. I'll just delete that ASM just to prove it to you. I will generate a new ASM. For those dropping in on this is a technical discussion. I'm going to drop that into this batch file here, and it's just going to create me an output file. And what it's doing is examining, looking for bank select errors in RAM with RAM memory. Okay, it's done it. I can now open up that report and put that into here, and you can see inside of the editor that I've got all the variables and which bank they were meant to be in and which bank they're actually in. So this is a variable. This one's called variable 32. That means it sits in memory address 32. As you come down, you'll see that there's different various addresses, and these addresses map directly to the chip. Okay, and it says bank 1 and it's in bank 1. But if I cursor down, let me have a look. These are actually, this is going through system ini. Look here, this is great. If I cursor down, I get to page 32 and it falls over in a heap. There we go. So page 32, anything that's in page 32 or bank 32, sorry, will be incorrectly addressed, and there are a lot of bytes sitting in that address there. Now, my assumption is that the source code, you haven't, you don't have that level of control with variable addressing, and that could be a string that's inside there or anything. However, anything that uses bank 32, the compiler will just refer back to bank 0 and corrupt other things. It will just corrupt it all over the place. So what's the issue here? Well, the issue is that, let me just see if I've actually got my Excel spreadsheet still here. I put together an Excel spreadsheet. Did I put it in? No, it might be sitting out in, it's sitting here. Look, there we go. Look. Energy resource. How do I open up what I've just closed? A bank cell there. So this is bank select. This is bank select here, and this is what the issue is that over in deep inside the compiler, when the compiler looks at a particular memory location, and this one, if I look at this one, anything between at 360, it gets a particular mask that's been assumed because and it actually thinks it's okay. But the reality is, this mask of 3968, which is the correct mask for chips that have been up to now, but when you get to a particular page and you mask it, you end up back at page 0. So let me explain. This is page 31. Anything with memory address 40002 to 40EF will get a mask, and it will say, yeah, that's fine. I'm sitting on, I'm not on bank 0. But the compiler, when it gets to page 32, it does the and it goes, I'm sitting on bank 0, and therefore does not put a bank select in the source. If I go back to if I go back into the editor here, and we look at the assembler for this particular code. This is the assembler for that code. If I look at bank 47, it says, okay, bank 47, I'm going to put 32 into a memory address at 1780, and trust me, that 1780 is bank 47. But notice it's number banksel move that variable. If I go down to bank 32, it just moves the variable, it assumes it's on 0, and that's why that report broke. So this is a bank select, all bank selects that are missing from here, and we got that proven inside of this file here, because this test is a bank select test. So we know we can fix, we know what the issue is. So I've revised the compiler. And hopefully I just need test programs to prove this is fixed. I'm just going to start up the new compiler. Let me just get rid of all these programs. Same program. I'm now going to look at. I'm just going to compile it up in the new, with the new compiler that I'm testing. I'm now going to open up those same files that we were looking at before. Here's the banks. I'll run the bank cell check. I'll do that again because we have to. Drop that on that batch file. Great, that's done that. Let me just put that inside of here, so we can look inside of here. And if we cursor down very quickly, we get to, there are no errors. I've been through that. You can see that visually there are no errors in there, so all those bank selects were correct. If we now look at the assembler for this, now we open up the assembler, go to bank 32. First of all, it's in its correct place, which is very strange. Bank 31, there's the number, bank select, and then move it into the correct variable address. Bank 32, I've now got it set up correctly. So hopefully that has resolved the issue. We'll only find out when someone has a look at it, yeah, later on.